Hi everyone, myself Navyatha, working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today I am going to discuss about normalization, and the overview of my presentation includes the types of normal forms. Here up to 3.5 NF we have already discussed in our previous sessions. In this particular session I am going to discuss about fourth normal form and fifth normal form. So let us discuss fourth normal form. So what is this meant for? If a given relation is said to be in fourth normal form, it should satisfy the following two conditions. What are those two conditions? It must be in BCNF, Boyce Codd normal form, and the table should not have any multi-value dependency. See, from the normalization, in the concept of normalization, in the first normal form, there must be no multiple values. The second normal form, it must satisfy the first normal form and no partial dependency. What is the third normal form? It must satisfy second normal form and no transitive dependency. What is 3.5 NF? The value of the LHS must be a super key. Okay. So what is fourth normal form? It must satisfy Boyce Codd normal form and the table should not have any multi-value dependency. So this is the term now we have to learn. What is multi-value dependency? So a table is said to be multi-value dependency if the following conditions hold. What are those conditions? If at all for a given dependency A tends to B, A has multiple values other than B. So if for single A, multiple value of B exist. Okay, for example, if A, that is myself. Okay, so A loves chocolates, again A loves ice cream. So here I have multiple values. Clear? So that is what the thing. I have enrolled in multiple courses. That is also here multiple dependency can be represented as like this. That means A is having multiple values to B. Okay. That is what multiple dependency. Again, A have multiple dependency on C. For example, this is the another column. I love chocolates, I love ice creams. That is what the thing here. And it is represented by the symbol like this, multiple dependency, double arrow mark. Okay. Now, so for a dependency A derives B, if a single value of A, multiple value of B exists, then the table may have multi-value dependency. And the second point is, what is the second point here? A table should have at least 3 columns. So minimum 3 columns. The table must contain minimum 3 columns. So you have multi-valued dependency. Next, what is the third one? For a relation, for the given relation, if there is a multi-valued dependency between A, B, then B and C should be independent of each other. This point especially will be discussed in the next example. Let us discuss this one. Okay, this is A, this is B, and this is C. Let us hope that. Okay. So here student ID, course and hobby. See here student. Here I can say that A is multi-value to B. See, the same student enrolled in 2 courses, computer and math. So we can say that here A is multi-dependent on B. Okay. Again, we can define one more functional dependency also. See, the same student has 2 hobbies, dancing and singing. See, A has multi-dependent on C also. Why? Because the same student have dancing, the same student have the hobby singing. Okay. And the third point, what is the third point? If at all, this one is dependent on this one and this one is dependent on this one, then rest of the columns, what? The RHS, these 2 columns must be independent of each other. These 2 must be independent of each other. That is what the condition. See, and for relation ABC, if there is a multi-value dependency between A and B and A and C, okay, A and B or A and C, then B and C should be independent of each other. See here, BC. How we can say that? See, these are nothing but independent. There is no connection. Course and hobby, computer dancing, math singing, chemistry dancing, biology, cricket, physics and all. These 2 are both independent of each other. That is what the thing here. So, if at all if at all the table contains in this manner, then we can say that it is the multi-value dependency exists in this particular table. Okay. So how we can able to overcome this one? Let us see. The same thing which I have explained. In the student relation, the student with student ID 21 contains 2 courses, computer and math, and 2 hobbies, dancing and singing. So there is a multi-valued dependency on student ID, which leads to unnecessary repetition of data. That means 21 has been repeated. That is what unnecessary repeated, right? So how we can able to remove that one? By decomposing the above table into subtables. How we can able to decompose? Just think how we can able to decompose. See here, student ID course one table, student ID hobby another table. Okay. So student ID course one table and student ID hobby. That is what another table. So student ID course 21 computer, 21 math, 34 chemistry, 74 biology, 59 physics. Okay. And the second one 21 dancing, 21 singing and 34 dancing, 74 cricket and 59 hockey. In this way we can able to remove the redundancies of the given data. Now let us discuss about the fifth normal form. So what is fifth normal form? A relation is in 5NF if it satisfies 4NF and no multi-value dependency must be removed here. Okay. So 4NF and not contains any joint dependency and joining should be lossless. Okay. So here comes the concept of joins. So to join two particular tables, what is the basic requirement that we used to know? What is the basic thing in join operation? If at all to join two tables, one common column must be there. Okay, to join two tables, one common column must be present. Then only we can able to perform join operation. So here, if a relation is said to be in 5NF, it must satisfy 4NF and the joining should be lossless and there is no joining dependency. That is what the thing. So here 5NF satisfies when all the tables are broken into as many as subtables in order to avoid redundancy. Why we are decomposing? What is the purpose of decomposing here? So if we used to decompose, then the rate of redundancy will be reduced. More repetitions will be reduced. That is what the thing. Next, 5NF is also called as, so it is also called as project join normal form, PJNF. Okay. So let us deal this one with the examples. What is join dependency? Okay. So if join operation for R1, R2. So this is what here, this is what the given relation R. This is what R. And this is R1, this is R2. Okay, this is R1, this is R2. So if at all, we used to join R1, R2, we must obtain R. That is what our intention. If at all we used to union R1 join operation R2, we must get what? R. So if we got this R after joining these two, then we can say that it is lossless decomposition. Okay, then we can say that it is lossless decomposition. So by doing join operation, we used to perform Cartesian product and one common column must be there with these two. If at all to join these two, one common column must exist. What is the common column here? B is the common column. Okay, B is the common column. So we need to do join operation here, Cartesian product. Okay. Then we have to obtain the original relation back. That is what our intention. If and only if we used to obtain that original relation back, then only it comes under lossless decomposition. That means any loss has not been done here. Okay. By considering with this theoretical part, let us explain this one in a practical manner. Okay. So let us consider here the relation. This is the original relation R, and this relation can be decomposed into two parts, R1 and R2. Let us assume that I have decomposed into AB and BC. That's what I have done. The given relation AB and BC. Why? Because to join we have to maintain one common column. Here I took B as a common column. So if at all I took B as a common column, then I got these two relations. Okay. Now what is a primary step? I need to join these two. Join means what here? I need to do Cartesian product. Okay. I need to do Cartesian product. Before going to that, let us consider one query. What is that query? To find the value of C, if the value of A is 1, I need to find the value of C. If the value of A is 1. Okay. When the value of A is 1, that is what my intention. I need to find the value of C when the value of A is 1. Okay. So now, whenever I used to decompose this table into two tables. Now the database contains only these two subtables. Okay. Why? Because I am decomposing this table into two tables. Now the database contains only two, not the single table. Clear? So, after combining these two, I want to get the value of C when the value of A is 1. Okay. That is what my intention. That is what my query also. To get the solution of this query, we need to join the above two tables, R1 and R2. We need to join these two first. Okay. We need to join. And what is the query representation here? Select what I want. That will be represented by using select. Select what I want. C. I want C value when A is 1. So, I select C. Where C is available in R2. Right. Where C is available. This is R1. This is R2. Right. I want R2.C. I want select R2.C from which table? This is nothing but from R2. Where R1.A is equal to 1. Where R1.A is equal, that is what my query representation. See, select R2.C from R2. What I am doing here? Join operation. Natural join operation with R1. I am going to join with this one. Okay. I am going to join these two, R1 and R2. With R1, where R1.A, this is what my condition. This is what the query representation. Okay. What is natural join operation will do? It will do the cross product, that is the Cartesian product, plus it will satisfy the condition also based upon some condition. This is what our main intention. Now, let us do the cross product here. What we will get? Cartesian product of these two tables. Consider these two tables and let us do the Cartesian product. So, what will be here? A, B, B, C. This is what our final result. So, here 1, 2. First row will be mapped with all the three rows here. 1, 2, 2, 1, 1, 2, 2, 2, 1, 2, 3, 2. And the second row is mapped with all the three rows here. 2, 2, 2, 1, 2, 2, 2, 2, 2, 2, 3, 2. Okay. Next, the third row will be mapped with all the three rows here. What is the third row here? 3, 3, 2, 1, 3, 3, 2, 2. Next, 3, 3, 3, 2. This is what the final Cartesian product. Now, we need to check. Here the common column. Right? The common column. So, here the common column B is what here? This will be BB. These are same. So, these are same. Next, 2, 3. These are different. So, this row will be rejected. Clear? Why? Because to do join operation, only common column. Based upon common column only, we need to retrieve the data. So, this row will be rejected. This is the common column. This is the common column. And this row, see, BB, 2, 3. This is rejected. 3, 2. This will be rejected. 3, 2. This will be rejected. Why? Because B's are different here. Okay. Next, 3, 3. This is the common column B. So, this only 1, 2, 3, 4, 5 rows will be retrieved by doing the Cartesian product. 5 rows will be retrieved. So, what are the 5 rows here? First, second and fourth, fifth and the last row. So, the resultant here is this one. See here, these are the 5 rows. Only this row will be rejected. This row will be rejected. Next, this row will be rejected. This row will be rejected and this row will be rejected. Only 1, 2, 3, 4, 5. 5 rows will be considered. Consider these 5 rows. Okay, only we have got these 5 rows after doing Cartesian product. Now, what is the condition here? I want C value when A is equal to 1. That is what my condition. I want C value when A is equal to 1. So, I want C value when A is equal to 1. So, here we got A values. 2 same A values. So, we got 2 different C values. Why? Because A is equal to 1, C value is 1. For A is equal to 1 only, C value is 2. Is that correct? No, it is not at all correct. Okay, we have done the join operation here, right? From the given table, so we have split it into 2 tables and we have done the join operation based upon some condition. Okay, we need to get the original table back, but here we are not at all getting original table. Extra 2 tuples we are getting. In original table, we have how many tuples here? Only 3. Original table we have only 3 rows. Okay. But after doing join operation, we have got 2 more extra. So those tuples, extra tuples are called as what? Spurious tuples. So in the original table, we have 3 tuples and after doing join operation, while splitting, we got how many tuples here? 5 tuples. So it is nothing but it is a flaw. Therefore, this is called lossy decomposition. This decomposition is called lossy. Why? Because we didn't get original table here. After doing join operation, we didn't get original table back. That is, our data is somewhat missing. It is flaw. That is what we call as lossy decomposition. So, and these extra tuples are called as what? Spurious tuples. In the original table, we have 3. We got 2 extra tuples. And those extra tuples, unnecessary tuples are called as spurious tuples. So, what we have to do now? What we have to do? So, just here, randomly, I used to pick, this is what my given relation. And I used to pick what? A, B, C is the given relation. Here I have divided into 2 subtables. What are those 2? A, B and B, C. Randomly I have done like that. Okay. But by dividing into subtables, we need to keep one point in mind. So what is that one point? The common column must be a key value. The common column must be a key value, key attribute. The common column must be a key value. Here B is nothing but a key attribute. B is nothing but a key attribute. Key attribute means what? It must be unique. Okay. B is not a key attribute. Therefore, it must not be considered as a common value. So, here let us check C. C is a key attribute. It is also having redundant data. It is not all, it must be not considered as a key attribute. Now, here let us check A. A has unique values. So, A can be considered as key attribute. So, now A can be considered as what here? For the given relation A, B, C, A is the common attribute we have to take. So, here A is the common attribute means here we can derive AB and AC. Why? Because here we need to take common attribute as a key attribute. Whatever the attribute that acts as a key, then that attribute must be taken as common attribute. Then we can obtain what? Lossless decomposition. Lossless decomposition. Okay. So, here without checking that one randomly, I have decomposed into A, B, B, C. So, we got what here? Some flaws, spurious tuples. So, we must remove whatever, whenever doing join operation, we have to consider one common attribute as key attribute. So, here we should follow one criteria to select common attribute. Common attribute should be a candidate key or super key for either R1 or R2 or both for the given relations. So, here only A has unique value. So, we should consider A as a common attribute. So, here with this AB, AC, only these 2. This is R1 and this is R2. These can be considered as the 2 sub-relations. Now, let us do the join operation here. Let us perform the join operation. For the same query, let us consider this one. For the same query, what I want to find the value of C when A is equal to 1. This is what my ultimate thing. Okay, I have 2 subtables, R1 and R2. Now, let us do the join operation. What we will get? 1, 2. The first row will be mapped with all the 3. 1, 2, 1, 1. Okay. Here A, B, A, C. Okay. 1, 2, 1, 1. Next. 1, 2, 2, 2. Next 1, 2, 3, 2. Okay. So, in the same manner, I used to map 2, 2, 1, 1, 2, 2, 2, 2 and 2, 2, 3, 2. So with this, I used to get the resultant after doing the join cross product. So I used to get these things. Okay. Now here I want the data. Here I am considering what here? A values, right? Common attribute as A. So only those columns will be retrieved. So here these two are common. A. These two are equal. Next, whether these two are equal? No. Whether these two are equal? No. Whether these two are equal? No. Next, these two. This first row is equal. Next, second row. These two are equal? Yes, A. This is equal. This row will be retrieved. Next, A. This is A. These two are different. A different. A different. Next, A common. This will be retrieved. Only 3 rows will be retrieved here. Okay. So here 1, 2. See here. 1, 2, 1. 1, 2, 1. Why? Because I have discarded this A. Only single A will be enough here. Okay. Next, 2, 2, 2. 2, 2, 2. This is row. Next, 3, 3, 2. 3, 3, 2. So this is the original table. See, 1, 2, 1. 2, 2, 2, 3, 3, 2. 1, 2, 1, 2, 2, 2, 3, 3, 2. If at all I used to join that ABAC, then I got my original table back. This is what the correct way of doing decomposition. We must not do just like that. Whatever, if at all we want to decompose, then we should check the common attribute must be a super key or a candidate key. Then only we can do that. What we can get, we can obtain lossless decomposition. Otherwise, we used to get lossy decomposition. That is what the thing. Okay. So this is what my original table, and I get back my original table. And for lossless joint decomposition, the condition, what are those conditions here? Here, if at all 2 subtables, if we unite 2 subtables, we must get the original table back. That is what R. Okay. And R1 intersection R2 must not be equal to pi. This is what my second point. So if at all we used to intersect these two, we must not get empty. Okay. And the third point is the common attribute must be a candidate key or super key of R1 or R2 or both. That is what the thing here. So in this section, what we have discussed about 4NF and fifth normal form, 5NF. Okay. So with this, we have completed the normalization concept. Thank you.